GATE 2017 Civil Engineering Set 1 Question 26. For the function fx equals a plus bx, where x is in between 0 and 1, to be a valid probability density function, which one of the following statements is correct? The four options are A equals 1, B equals 4, B, A equals 0.5, B equals 1, C, A equals 0, B equals 1, and D, A equals 1 and B equals minus 1. The relevant NPTEL reference has been listed. So coming to the useful data, if we are given the probability density function for a random variable x, so let us make the graph on the coordinate axis where fx is on the y-axis and the random variable's value is on the x-axis. So let us assume a typical shape for the PDF. So if we assume the lower limit to be x1 and the upper limit for the value to be x2, and we want to find the probability when the random variable lies in between these two ranges. So in order to find that, what we do is we integrate the PDF fx dx from x1 to x2. But what usually happens is, if x1 tends to minus infinity and x2 tends to infinity, that means we are covering the whole range of real values that is possible for the random variable. So this integral in that case turns out to be 1. That is, the probability density function when integrated over the whole range of values from minus infinity to infinity will give out the probability value, which is a total of the probability, to be 1. In this case, we have been given the value of the function fx equals a plus bx, and the limits are given as 0 to 1. So integrating fx from 0 to 1 should give us the total probability value to be 1, as we saw in the previous slide. So integrating a plus bx into dx from 0 to 1 should be 1. This ensures that a, the integral of the rest of the terms, will be x from 0 to 1, and similarly plus b, the integration of x would be x square by 2, the limits from 0 to 1 is 1. This becomes a into 1 minus 0 plus b by 2 into 1 minus 0, which will be 1. Solving this would give us 2a plus b equals 2. From this, by verifying from the options, we can get the value of a as 0.5 and the value of b would be 1, which would add up the value of 2a plus b to be 2. Option B, a equals 0.5 and b equals 1, was found out to be the correct answer for the function a plus bx to be a valid probability density function. The relevant NPTEL reference has been listed.